Hello, good evening, everybody. How are you? I hope that you all are all come up for today's sessions. Welcome to the chemistry talks today. I hope that today you will be able to enjoy as much as you can, and hopefully, you all will have fun. Okay, in the meanwhile, if you want to ask questions, you can always feel free to do so. Okay, I'll be able to help you as much as I can. Are you all ready? With that hesitation, shall we begin our program today? Okay, good afternoon, everybody. Today we are going to talk about this technique of answering STPM chemistry for term 3, semester 3. Thank you for joining me. I hope that all of you have already taken your lunch and are ready for the talk today. To those who are not aware of what we are going to use for discussion today, you can click the description in the YouTube below. Inside there got my blogspot. You can download the questions and answers in there so that you'll be able to focus more on the how to answer the questions. This live is probably going for 2 hours, and I hope there is a little break in the between, let's say around 5 minutes. I hope that today's talks will be able to benefit all of you. Without any hesitation, shall we begin? Now allow me to do a little self-introductions to those who don't know me yet. So let's begin. So hello, my name is Mr. Chu Chin Kun. I'm more known as Chu Sensei. I'm 41 years old already, 2022. I'm originally from Pontian, Johor, and currently teaching in SMK Tasik Utara. This year has been my 19 years of teaching. Next year will be my 20th year of teaching. I'm actually a little bit excited. 2 decades of teachings and lots of sweet memories with all my ex-students. I've been teaching STPM since the day that I started to teach, starting to become a teacher. So I hope that with all the experiences that I gained throughout my 19 years of teaching, I'll be able to share with all of you whatever experience that I can have. In the meanwhile, if you have any questions, you can always just let me know, and then inside here I'll be able to highlight your comment if you have any. If you have any comments, I'll be able to highlight here. For example, I show here. So I'll be able to answer your questions straight away from the this one. It'll be a very interactive YouTube live. Just feel free to ask if you have anything that you are not sure. Without any hesitation, shall we begin? I was this national trainer for STPM new syllabus from 2012 to 2017. I also marked for STPM for section B and C from 2012 until 2017. National moderator X, can I say X? Because nowadays I don't do all this anymore. I'm a motivator and lecturer that gives talk about STPM chemistry and technique of how to answer STPM worldwide, nationwide, worldwide, nationwide. Since 2008, I've been writing a few books. Last time we have Project A. I don't know whether you still have it or not. STPM Chemistry Exercise and Practices by LP Publications. And I'm also currently publishing my own absolute guide for STPM Chemistry. And I also own my blogspot, chemiststorychu.blogspot.com. You can always feel free there. I'm also the owner of this YouTube channel, Chu Sensei. Nothing much. Now, let's together have a look at the format of the paper. So you have already going through 3 semesters already. So I believe that all of these are not strange to you anymore, nothing new to you anymore. It is still the same format where we have 3 terms, 3 different papers of this one, but same format where you have a written test, section A, 15 marks, compulsory to answer multiple choice question. Section B, 15 marks on 2 compulsory structured questions to be answered. And then section C, 30 marks for 2 questions to be answered out of 3 essay questions. And I believe that your school has already submitted your paper 4 marks. Okay, a 225 total marks of 20% from experiment 1 to 13 plus project work throughout the semester 1 until semester 3. And I believe that most of the teachers are able to will be helping you on this one. Okay, so you have already scored around 18 to 20 marks already. So the remaining, if you are aiming for A, then probably you are going to score another 57 marks. And then if you are probably aiming for pass, let's say, so you probably have to aim another 21, 22 marks. Okay, so let's together do our best. Okay. Okay, so pay attention. Okay, so before the examination, so I have already, you have to make sure that you read all your details of all chapter in chemistry. It's possible, make our own short notes based on your understanding and check with your teachers or reference book or online sources. And then you try to do all past year questions. We have from 2013 until 2020. So altogether you have 10 set. Okay. 10 set of the past year questions, so make sure that you do all of them so that you'll be able to understand on how the format is going to be. Okay, and then you also should, I also encourage you all to do a group studies with your friends. Okay, so usually it is the best way for you to study STPM, and because you hardly survive on your own, as the school or STPM are too wide to cover. So you can also exchange ideas among each other. Okay, so I believe that you have already realized it just right now, isn't it? Okay, that it is the best way for you to study together with your friends. Okay, okay. So this is it. So these are a few tips that I can share with you in order to make you studies. And then one more thing is, if you bought my books, there is a mind map for organic chemistry. So starting from today on, you can every day do one mind map. Now, if you don't buy my books, it doesn't matter. You can still download the mind map for free through my blogspot. All you have to do is search Google STPM chemistry. You will probably see my blogs, chemiststorychill.blogspot.com, and browse the content a bit, and you'll be able to find my blog, and you'll be able then download the mind map. I think I have already attached the answer together with it so that you can check your answer. Okay, so you have to do this on your own. You have to remember all the reagent and condition, what become what. So very, very basic, very, very important for the basic revisions in here. Okay, okay. So without any hesitation, shall we begin our talks for today? Okay, so in the middle way of my talks, you can interrupt me with any questions that you want. All you have to do is type out in the comment. If I see questions in the comment, I will immediately click on the screen and explain to you immediately. Okay, so hope that you all will be able to understand. I'll be able to help you all as much as I can. Okay, okay. So shall we begin? Okay, so let's do it. Okay, so we are going to start with the trial from my school examinations. Okay, thank you very much to my school teacher, Mr. Yi, also, who helps me to set up the objective questions for this. So I'm going to discuss all of this. Okay, so your advice for section A here is you are not advised to spend too much time in answering section A. Advisable maximum allocated time is somewhere between 20 to 25 minutes. Okay, so in other words, it's like 1 minute 20 seconds per question. Let's say if you use 20 minutes in here. Okay, so this is the time. Organic chemistry, not much of a calculation. It's very applicable. Mostly are applications questions and also understanding question. So nothing much to be consider about, except when they really calculate most things and it will take a little time for calculation. The rest of it is just more for analytical point. Okay, so you should be able to do it very fast. Okay, so let's have a look from each of the questions where we are going to discuss how we're going to answer it. Are you ready? Okay, let's do it. Okay, so number one sounds like this. A chemist produced methyl salicylate from salicylic acid, which is used in the production of the wintergreen oil. In the esterification above, X represents one of the following process. X is the what? So what is X in here? Now, if you notice carefully, the changes in here are, if you can see carefully, the changes in here are how you change from COOH to become COCH3. Do you see that? Okay, how does carboxylic acid become ester in here? So how does carboxylic acid become ester in here? So you have to use something with the alcohol with the carboxylic acid, isn't it? So sorry. Oh, I really just press escape. Oh, okay. Okay, so what could be X? So X is esterification. You require functioning group of COH to form COCH3. Therefore, you use methanol catalyzed by concentrated sulfuric acid. Okay, methanol catalyzed by concentrated sulfuric acid. Okay, so very obviously the answer here is C. Okay, sorry, I scroll too fast. Okay, so the first answer is C. Okay. Okay, so this is for question number one. So any questions? Okay, a little bit of the revisions goes like this. Okay, now if you, let's say today the questions ask you esterifications for let's say the OH part in here. Okay, so for the OH part in here, it is, you must use SU chloride. You must use RCOCl. My computer is a little lag. Sorry for that. Okay, RCOCl. Sorry, my computer is a little lag in here, so I also don't know what is going on. Okay. Okay, RCOCl. So it must be in SU chloride, catalyzed by the in alkaline condition. RCOCl in alkaline conditions. So this is only true if you want to react phenol. If you want to react phenol, then you have to use RCOCl in here. Okay. Okay, so this is the first one. So shall we move to the second questions? Okay, so second question sounds like this. Vitamin C has the following structure. So how many chiral center are there in one molecule? So you have to circle out. So which one is a chiral carbon atom? So you can see from here, this is the most obvious one. Now, is this the only one which is a chiral carbon atom? No, this is not the only one which is a chiral carbon atom. You also have here CH in here. So anywhere else that have two chiral carbon atoms? Okay, no more. So this is the only two chiral carbon atoms that you can find here. So the answer in here is B. Okay. So the answer in here is B. Okay. Okay, so this is how you are going to answer number 2. Okay. Okay, any questions so far? Should be quite easy. So if no problems, let's immediately move to number 3. Which aldehyde will form a ketone when heated with acidified potassium manganate solution? Okay, so now let's together discuss the products for each oxidation reaction, shall we? So what is the product of oxidation for each of them? So A will form what? Okay, A will form propanoic acid with carbon dioxide and also water, isn't it? Okay, ethanoic acid, propanoic acid with carbon dioxide and water. Okay. Okay. What about B? B will form what? So B, when oxidized, it will break in between the C double bond C, carbon cleavage take place. You will form ethanoic acid plus propanoic acid. Okay. Okay. Number 3. What about number 3? Okay. So number 3, you will be forming 2 propanoic acid. 2 propanoic acid. Okay. And last but not least, okay, D will be forming a ketone, which is a propanone plus CH3COOH, ethanoic acid. Okay. So based on the answer in here, the best solutions in here, the answer for this question number 3 is D. Okay. So this is the answer for number 3. Okay. Very straightforward. Huh? So any questions so far? Okay, so hopefully no problem. Okay, no problem. Then immediately we goes to question number 4. Which of the compound released nitrogen gas when it reacted with nitrous acid? So let's together have a look at the solution for each of them, shall we? Okay, so for the when react with nitrous acid, so primary amine group will form alcohol, hence release the nitrogen gas according to the equation RNH2 NaNO2 plus HCl 0 to 5 degrees Celsius. This one is 0 to 5 degrees Celsius to form ROH plus nitrogen gas plus NaCl plus H2O in here. Okay. Okay. So therefore, which of them is a primary alcohol? So the answer A is a primary alcohol. Okay. Now B is a secondary amine. B is a secondary amine. Okay. C will eventually form, C is an amide. So amide can also releases this gas, but it is not nitrogen gas. What is the gas release when you when reacted with this one? So you form you form this carboxylic acid. So I just straight away write the functioning group in here. Sorry, supposedly can, can write something on it. Okay, so this one C will form this propanoic acid. Okay, you will form propanoic acid plus ammonia gas. It is the ammonia gas NH3. Okay, not nitrogen. So and then D for tertiary amine. So tertiary amine will react with nitrous acid simply just to form a salt because amine is basic. So when you react with acid, it will form salt in here. Okay, so that is why number 4 is A. Okay, so can you understand? Yeah, so if no problem, let's move on immediately to question number 5. Okay, polychloroethane is manufactured by free radical processes where chloroethane is heated under high temperature, high pressure with benzoyl peroxide. Which of the following is a propagation steps in this reaction mechanism? Okay, so A. So A is what step? Okay, so A is actually just combining the C6H5, C6H5 putting 2N. So it has no significant meaning for A. So A is nothing. So what about B? B is a what step? B is actually a termination steps. B is actually a termination steps. So it is not propagations. What about C? C also similarly termination steps. It is also a termination steps. Okay. And finally for D, so D is how the radicals are able to attack the C double bond, CH2 double bond to propagate to prolong the number of the hydrocarbons in here. Hence, the best answer for this is a D. Okay. So propagation step of a free radical polymerizations involve free radical attacking the pi bond in C double bond C of the chloroethene and prolong the chain of the polymer. So therefore, the best descriptions that shows that it is a propagation steps is D. Okay. Okay, so that is for number 5. Okay. Okay, any questions so far from number 1 to number 5? Which part in here they can understand? Okay, so if no problem, then immediately we goes to question number 6. When phosphorus pentachloride is added to an organic compound X, hydrogen chloride film will be released. If substance X is heated with potassium dichromate, solution change from green to color to green. Potassium X is most probably what? So the only one that can react with pentachloride is anything with a OH, anything with a OH, okay? So this will make it to become either a carboxylic acid or is it a pride alcohol in here. So if you look carefully, A is a aldehyde, B is a secondary alcohol, C is a propanoic acid, and D is a tertiary alcohol. Okay, so when species can react with PCl5, indicates that it contains OH in it. Therefore, it is either OH or COOH. And finally, when X can be oxidized with K2Cl2O7, it indicates that it is either a primary or secondary alcohol. So which one is your best answer? So your best answer in here is boy B. Okay. Sir, for question number... Okay, so some of you ask, sir, should for question number 2, shouldn't be answer A. Now, in question number 2, should it be A or not? Now, never mind, let's scroll up back to number 2. Okay, why there are 2 chiral center atom, okay, as I circle out in here. Okay, there are 2, not 1, 2, okay. So I hope that it solves your problems, okay. Can, okay, so that is for number 2 just now, okay. Okay, immediately we go to number 7. Okay, given the following compound P and Q, the following methods can be used to differentiate organic P and Q except, so which one can distinguish P and Q? Except, so you are finding those which cannot. So A, adding Tolan reagent, so you can distinguish it because Q is definitely will give a positive test due to the presence of the aldehyde group. Okay. Okay, teacher, no idea about benzoyl peroxide. Benzoyl peroxide is slightly out of the syllabus, but what they are stressing here is how does the propagation steps occur? Okay, how does the propagation steps occur? Okay, so this one is the free radical polymerization, which is in the old syllabus. But the key, as I told you, the key point is of the propagation steps. Okay, so it doesn't matter what syllabus it takes, as long as you understand the propagation steps, so it shouldn't be much of a matter. Okay, okay, so back to question number 7. So warm with Fehling solution. So in Fehling solution, Q also will give a positive test due to the presence of the aldehyde. Okay, due to the presence of the aldehyde. Okay. Okay, C, heating under reflux of alkaline iodine solution. So both P and Q will give positive because both has methyl carbonyl group. Both has methyl carbonyl group. Okay. Okay, and then for D, heated under reflux in acidified potassium manganate because Q is aldehyde, so it can further oxidize. Okay. Okay, I see some of the questions in here. Allow me to go through. Okay, wait. Okay, teacher, can you draw the structure for D or not? Okay. It's not like I cannot draw, because I have my difficulty of the 3D. I have my, then I already show you. You missed that already. Okay, you missed that already. I already show you in here lah. Okay, it's inside there. Okay. Okay. Yeah, so shall we continue? Okay, then we continue to number 7. Just now the answer is C lah. Number 7, the answer is C. Let's go too fast. Okay, the answer number 7 is C. Okay. Okay, then let's go to number 8. So the pKa value of 4 organic species are shown below. So you have benzoic acid 4.20, 2-methyl benzoic acid 4.26, anilinium ion 4.58, 4-methyl anilinium ion is 5.10. Based on the data given, which of the statement is true? Okay, so which is this true? So in here, benzoic acid is the most stable species. So you see because anilinium ion has the highest pKa in it, therefore it is the weakest acid, while 4-methyl anilinium, not 4-nitro, 4-met adoy, Mr. Chiu ni teruk sangat lah. Sorry typing error can you pardon me for this one? Mr. Chiu now will correct some of the typing error inside here. Okay. Not 4-nitroanilinium is the benzoic acid. Okay. Okay, so let's scroll back to this one. Okay. So in here, so benzoic acid is the strongest acid, hence the least stable. So in here, the concept goes like this, please bear in mind that stronger the Bronsted lower the pKa, okay, lower the pKa, stronger the acid. Sorry, I scroll back. Okay, lower the pKa value, stronger the acid. So when you have a stronger acid, it means that it tends to react, it tends to dissociate, it tends to react. Therefore, it is the least stable. It is the least stable. Okay, so that is why benzoic acid is the least stable species. Okay, and the B saying that 4-methyl anilinium is more stable than 4-methyl benzoic acid is true because, as I mentioned just now, stronger the Bronsted-Lowry acid, weaker the conjugate base. So when you have a weaker conjugate base, okay, that means it is more stable. So 4-methyl anilinium ion is more stable than 4-methyl benzoic acid because the pKa value of the anilinium ion is lower. So it is the most stable. Okay. As for C, 4-methyl anilinium is weaker base than aniline, also wrong. Okay. Because the pKa value of the 4-methyl anilinium ion is higher. Weaker the acid, stronger the conjugate base. Okay, so therefore aniline is a stronger base than 4-methyl aniline. And finally, 4-methyl anilinium ion is the most acidic, which is wrong. As we mentioned just now, benzoic acid is the strongest acid in here. Okay, so that is why the answer in here is B, boy. Okay. Okay, so the more stable, the weaker the conjugate base, the more stable it is. Okay, so in other words, something that is weaker, it don't like to react. So when it don't like to react, that means it is more stable. So that is the key of all this. Understand? Okay. So immediately let's go to number 9. Which reactions represents a substitution reaction which occur through electrophilic mechanism? Okay, so we have A, the first one, if you notice carefully, it is the CH2Cl replaced with NH2. So NH2Cl, so it is the type of the nucleophilic substitution reaction. And then for B, when you have ethylene benzene, when you react with HCl, this is an electrophilic addition. And then the C, CH3Cl2 under UV, you form CH2Cl plus HCl. This is a free radical substitution. And then finally for D, so when you react methylamine with the, when you react toluene with Cl2 in FeCl3, so it substitute is electrophilic aromatic substitution reaction. So the answer in here is donkey D. Okay, so I have questions in here. Some of you started to ask this. Okay, so I'm going to answer you. Okay, when writing mechanism of electrophilic aromatic substitution, is it necessarily to use the Hercules benzene structure? Yes, advisably yes. The latest syllabus requires students to use the Hercules structure. That means the double bond thing lah. Okay, so for more information, you can always refer to my YouTube. Okay, or if you already bought my books, the one inside the books is already there. Okay. Okay, so I hope that it explains. Huh? Okay. So let's continue back, shall we? So this is number 9. I have one more. Sorry, I answer whenever I can. Huh? I answer whenever I can. Huh? Okay, sir, when should I write the reactant above the reaction line? That it doesn't matter. It doesn't matter. You can write above the line. You can write beside the line. It doesn't really matter. As long as the reagent and conditions are correct, then it should be okay. Okay. Okay, so okay, so let's continue to number 10. What is the volume of the oxygen for a complete combustion involve 5 centimeter cube of CH4 and 5 centimeter cube of C2H4? Okay, so first of all, you need to balance the equation. CH4 plus 2O2 gives CO2 plus 2H2O. So according to Avogadro's law, so 5 centimeter cube of CH4 require 10 centimeter cube of O2 lah. And then you have C2H4 plus 3O2 gives 2 CO2. Actually, there's 2 CO2. 2 CO2 plus 2 H2O. So 5 centimeter cube require 15 centimeter cube of the oxygen. So total volume of oxygen will be 10 plus 15, which is equals to 25. Okay. Okay, so that is for number 10. Huh? Okay, then we look for number 11. Propanoic acid is heated with concentrated ammonia to produce X. Which statement is about X? So X is actually what? So if you react CH3COH plus concentrated ammonia, you form the amide CH3CH2CO NH2 plus NH4Cl. So A, X is basic. So based on this, is amide basic? No, amide is neutral. Okay. B, compound X react with ethanoyl chloride to form N-ethyl propanamide? No, because carboxylic acid derivative cannot react with carboxylic acid derivative. Okay, so that is why it cannot have reactions. And then C, compound X react with cold nitrous acid? Yes, it can. So to form CH3COH plus N2 plus H2O. And finally, compound D, compound X undergoes esterification with alcohol in the concentrated sulfuric acid, because you have to know that amide does not undergo esterification in that situations. Okay, so that is why D also incorrect. So the best answer in here is C. Okay, so I hope that it helps you to answer this one better. Okay, okay, so any questions for number 11? Okay, so far, is there any question for number 6 to number 11 or not? Feel free to ask if you have any. I'll highlight when I see the questions. Okay, so if no problem, then immediately we go to question number 12. Now, which is not true about an electrophile? So what is an electrophile? An electrophile is a species that is lack of electron, or usually positive ions. The terms electro means electron, love, phile means love. So love electrons. Okay, so which species is love electron? Let's have a look together. It is a Lewis base. Okay, so electrophile is an electron pair acceptor. Therefore, C is correct. Okay, hence Lewis acid, Lewis acid, not Lewis base, because Lewis base is electron pair donor. Okay, so it can be produced from the haloalkane, where you have CH3 plus Cl minus. So B is also correct. And then D, it forms heterolytic fissions. Yes, in heterolytic fission, as you can see from the equation here, you form CH3 plus and Cl minus. Okay, so you can form. So the one which is not true in here is it is an electron pair acceptor. Okay. Sorry, A. So this one is A. Sorry, I highlighted wrongly. Can you pardon me on this? Sorry, this A. So the answer is A. Sorry, Lewis base. It is a Lewis acid. Okay, so number 13. Which reagent can react with ethanol and phenol? So in order to study whether they can react with ethanol or phenol or not, let's have a look together one by one. What are the products for the reactions in here? So let's have a look together, shall we? So what are the products of the reaction when you react with bromine water? So when react with bromine water, you form 2,4,6-tribromophenol. Okay, 2,4,6-tribromophenol, while ethanol has no reactions with the bromine water. And then B, when you react with potassium hydroxide, so potassium hydroxide will form salt plus water for phenol, while no reaction for ethanol. And then number 3, so iron 3 chloride, so you form Fe3 plus phenoxide ion 3, so you observe as a purple solution, while for ethanol, no observable changes. And last but not least, propanoyl chloride can react with both phenol and also ethanol to form the respective ester in here. Okay, so that is the answer for number D. So that's why number 13, the answer is donkey D. Okay. Okay, so is there any questions for number 13? 12, 13? So I hope that there is not much of a problem so far because they are all quite direct, the questions. Okay, so hopefully you can do it. Okay, ionization. Let's have a look at question number 14. Citric acid has the following structure. So you have that structure, which is the following is not true about citric acid. A, it decolorizes potassium manganate. No, it does not decolorize because of the tertiary alcohol. Okay, B, it reacts with LiLH4 to produce the following product, which is true. Okay, so it produce primary alcohol. So anything with the COOH will be reduced to become CH2 and CH2OH. Okay, and C, it is optically not active. So because there are two similar surrounding groups, so C is correct. And then D, it is a solid at room temperature. It is also correct. So the best answer in here is A. Okay. Okay, so that is for number 14. Okay, is there any questions that you want to ask for number 14? Okay, so with ionization, let's have a look at the next one, shall we? Okay, last but not least, the last objective questions will be number 15. Compound X react with concentrated ammonia to form N. N treated with LiLH4 in dry ether followed by acidic hydrolysis, propanamine is formed. So M could be what? So you have to use the reverse method. So the reverse method in here, so M must be what? N must be what? So it threw out in here, M must be amide, N must be SU chloride. So the best answer in here is C. Okay, I repeat, N. The N, not M. N is an amide, and then M is an SU chloride. Okay, so the best answer for M in here is C. So this is the answer for the question number 15. So there you go. All the 15 objective questions I've already discussed through with you together with the solutions. So is there any questions that you want to ask for objective questions? Okay, so I hope there is not much of problems for objective questions. So I hope that it is clear enough for you all. Okay, okay. So with ionization, let's move on to the structure question, shall we? Okay, so let's have a look at the structure questions. Okay, so for structure question, section B is another 15 marks. So answer all questions in this section. So my advice to all of you in here is you have to spend about 15 to 20 minutes in answering this section. Okay, that means one question, 10 minutes. Okay, so answer, try your best to be short and clear and do not over focus only in one question. Okay, okay. So because of this, the time remain will be 45 to 50 minutes. Okay. Okay, so let's have a look at the questions that I've already prepared for you. Hopefully, you'll be able to know how to answer. Huh? Okay, number 16. Creotyl alcohol with that structure is a colorless liquid which is used as a solvent. A. Explain the stereoisomerism present in creotyl alcohol and draw the isomer status in here. So this is the geometrical isomerism. Geometrical isomerism. Okay, so why does it exhibit a geometrical isomerism? Because questions want you to explain, isn't it? So you have to explain why does it exhibit a geometrical. So it is due to each carbon inside the C double bond C is surrounded by two different atoms or group of atoms in here. Okay. So each C carbon inside the C double bond C is surrounded by two different atoms or group of atoms in here. Okay. So that is why it can exhibit geometrical isomerism. Okay. Okay, and then the isomer present, so you draw both of the structure in here, as in like this. Okay, so if possible, also label. So if you label the structure, okay, so this is your cis isomer. I'm also not sure what is going on. Sorry. Okay, so this is cis isomer though this is cis isomer cis isomer. Then the other one is trans. Okay. Okay, so this is for 16A. Okay. Okay, then we go to 16B. In the boxes below, draw the structural formula of the organic compound or compounds when formed when creotyl alcohol is react separately with each of the reaction under suitable conditions. So A, hydrogen gas catalyzed by the platinum. Okay, so when hydrogen gas catalyzed by platinum, so you'll be able to form to undergo hydrogenation. So you form benzene, CH2, 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 CH2OH. So that is for number 1. Okay. Okay, number 2. Reaction with phosphorus pentachloride. So from the structure, phosphorus pentachloride will always only react with alkyl alcohol, not the phenol functioning group. So in this case, the C double bond C will still remain. C double bond C will still remain. So you form benzene with a CH double bond CH2 CH2Cl in here. Okay. Sir, why doesn't benzene undergo hydrogenation? Benzene can only undergo hydrogenation under high temperature, high pressure. Okay? High temperature, high pressure. So in this case, benzene will not hydrogenate. Okay? Okay, so I hope that it answer to your questions. Some of you, maybe if you missed the question, I show you. So why does not the benzene undergo hydrogenation? Benzene can only undergo hydrogenations under high temperature, high pressure. So the questions will definitely say that if it is under high pressure, then benzene can undergo hydrogenations. So I hope that it answers to your questions. Okay. Okay, so let's continue. Number C, what happens if you react with bromine water? So be careful, bromine water, Br2AQ, will form what we so-called as a halohydrin. Okay, so there are two answers in here. Either you write as a benzene with OHBr or the other way around, BrOH. The key in here must be one Br, one OH because it is bromine water. And the rules follows the Markov-Nikov rule. Markov-Nikov rule stated what? Markov-Nikov rule stated that in the addition of the HX to C double bond C, H will be added preferably to the carbon with more hydrogen. Or in another way, it's also trying to say that the hydrogens will be this nucleophile will be attached to the carbon with more substituent. Okay, so that is the two ways of how you can define Markov-Nikov rule. Okay. Okay, last but not least, number 4, hot acidified potassium manganate to form benzoic acid. Teacher, what about side product? Usually side product in a separated hydrocarbon will become carbon dioxide and water. Okay, carbon dioxide and water. Okay, so with that, that is how you are going to answer about 16A. So immediately, let's go to the 16B. 17. Okay. So 17 sounds like this. A color dye Y can be synthesized using 4-nitroaniline from the following reactions. Okay. So you have X, Y, and then you have reagent A. definitely the first thing is to ask you how to fill in reagent A and compound with X and Y in here. So reagent A in here, you have to answer both concentrated HNO3 and concentrated H2SO4. So you form NH2 to become NO2 in here lah. Okay. Okay. So then NH2 become NO2 when reacted with nitrous acid lah, NaNO2 in HCl 0 to 5 degrees Celsius. They are trying to tell you that only amine can react with this. Only amine. So you form benzene diazonium chloride. Okay. Okay. And last but not least, when you react with the phenol, so you form the azodine in here. So this one must be in alkaline condition. So this one must be in alkaline condition. So what is the purpose of alkaline condition? So that you can produce a phenoxide. So that you can produce a phenoxide ions in here. Okay. Okay, so I see questions in here. Sorry, can I scroll back? Okay. Sir, in what condition can benzene undergo bromination? Br2 in FeBr3. Br2 in FeBr3. Okay, so I hope that it answered to your questions. Okay, so this is for reagent A, X, and Y. And then we have next one. State the type of reaction between compound X and aniline Y to form Y. So you form electrophilic aromatic substitution reactions. Okay. And then C, compare the basicity between aniline 4-natrilamine and 4-nitroaniline and ethylamine. So in here, the lowest definitely basicity increase from 4-nitroaniline, then aniline, then ethylamine. Okay. So why is it like that? So we have to mention because ethylamine is contains the electron donating group which stabilize the aminium ion form, whereas phenyl is a stable electron withdrawing group, causing the anilinium ion form to be less stable. So that is why equilibrium shift more to the right for the case of when you have a phenyl inside there. Okay, so that is for question number 17. Okay, so can I scroll? Some of you start to ask question already. Okay, so teacher, if answer electrophilic substitution for the mechanism and no aromatic, it is better for you to write the word aromatic. However, there are certain year, 2019, if I'm not mistaken, I received information saying that electrophilic substitution is also accepted for the aromatic, but like I always say, I always mention aromatic inside the answer I try your best to state the word aromatic. Okay, try your best. But in 2019, they accepted the word without aromatic. Okay, so if you just write electrophilic substitution is fine. Okay, but like I said, usually when I teach a student, I will not ask them to shortcut. Definitely write in full name, electrophilic aromatic substitution reactions. Okay, okay. Question 17, structure of azodine got error. Can I scroll back and see got error or not? Wait. Okay, is there error in here? I don't think so, isn't it? I don't think so. Got error, Mr. Edward. It is like that. It is like that. Oh, okay, yeah. NH2. No, thank you, Mr. Edward. Thank you very much. It is NH2. Yes. Thank you very much. Ayo, I blur already. Thank you, Mr. Edward, for helping me. I also blur already. Thank you very much. It's NH2 lah. Can you help me to correct the NH2 part in here? Okay. Okay. So it's NH2. Thank you very much, Mr. Edward. Adoy. So I also become blur already. Okay, thank you. Okay, so shall we continue back to okay, so with that is for this one. Okay, so that is for the structure questions. Okay, then we got 17. Next one. State the type of, okay, compare the basicity between aniline, 4-nitroaniline, and ethylamine. So basicity increased from 4-nitroaniline, aniline, and ethylamine. Okay. So in here, LQ group in the ethylamine act as an electron donating group, therefore stabilizing the aminium ion. Actually, you don't write the word stabilizing aminium ion, is okay, doesn't matter. Okay. Okay, don't worry, can, don't worry, no problem. Okay, teacher, is there any problem? Some of you asked this already. Teacher, is that correct? We don't write stabilizing, only write this one is electron withdrawing donating. Can, sorry, can, it's enough already. Okay, don't worry. Okay, then for the benzene, phenyl is a, sorry, too fast. Okay, then benzene act as a phenyl act as an electron withdrawing group, causing anilinium ion to form to be less stable. So just say phenyl is electron withdrawing group is enough already And NO2 cause inductive effect. Okay, or you said further destabilize the anilinium ion also can. Okay. So the NO2 will direct the electron toward it. So when you direct the electron towards the NO2, because NO2 is electron withdrawing group, you'll be able to withdraw the electrons away from the nitrogen, causing the positivity to be less stable. So teacher, what does it mean by NO2 is an electron withdrawing group? Why does it withdraw the electron? This one you have to go through the resonance structure of the NO2. So for more information, can you please Google a little bit about the effect of the NO2 as a electron withdrawing group? There is this resonance structure that causes the NO2 to be withdrawn away. I'm not able to show you in here because it will take some time to find out for you. So I hope that you won't mind to Google it on your own. Okay, so these are the answer for it. Okay, so with that, that is all for the structure answer. Okay, any questions in here? What is aminium ion in C? Aminium ion is amine in positive charge. Some of you asking, teacher, what is aminium ion? Aminium ion is amine in positive charge. Amine in positive charge, aminium ion. Okay, any else question before we move on to the last section, which is the essay questions? Okay, so if there is no problem, so with that, that is for the structure questions. So I hope that you'll be able to answer all of them well. Now, this chapter is very, very basic and very, very important, frequently asked in STPM examinations. So you have to, this one, conjugate acid. Why with conjugate acid? Jack. Okay, so you want to ask something, Jack? Okay, so so far I think that's for this one. Okay, so we go to our last section for today. Our last section for today is section C, 30 marks. So you only answer 2 questions in here. Okay, answer only 2 sections in here. So you are advised to spend 20 to 25 minutes in structure and essay. Do your best to present in an essay with full content related to the question. So point form, table, mind map is all allowed in answering for STPM chemistry, but usually we don't really advise you all to use all these kind of the short form unless you're very confident with your answer. Then if not, then you better avoid to use. And then try to avoid contradicting statement. What do I mean by try to avoid contradicting statement? Sekejap you said yes, then after that you said no. So that is contradicting. So usually examiners, they will take the first answer, not the second answer. Okay, and in some case, some examiner will penalize +1, -1. Wait, I show your question. So teacher, for inductive effect, should we mention positive or negative? No need to mention, because usually inductive effect is referring to negative inductive effect. Positive rarely mentions says that it is positive. If positive, we just say the electron donating. Okay. 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 Anything else? Okay. So this is a little bit of technique of how to answer structure essay question. So please read through every single details of the objective, then you answer accordingly. Yeah. Okay. Okay. So in the next session, let's have a look at the questions that I prepared for you. So we start from question number 18. Okay. Question number 18 sounds like this. Two gaseous hydrocarbon A and B have the same composition by mass. So carbon by 85.7% and hydrogen 14.3%. When 0.020 mole of gas A and 0.020 mole of gas B are both burned separately, product of the combustion are passed through anhydrous calcium chloride and then through potassium hydroxide solution. Masses of anhydrous calcium chloride and potassium hydroxide increase by 1.08 and 2.64 gram respectively. When mixed with bromine under sunlight, both gas A and B are decolorized the brown vapor. However, only gas A decolorized cold dilute alkaline potassium manganate, while gas B will not. Okay, so I hope that you understand the question. These are two separate things. Okay, so let's together answer the above section first. Calculate the empirical formula for both gas A and gas B, 2 marks. And then calculate the molecular formula for both gas A and gas B, 5 marks. Most of the students, they will see empirical formula very easy to calculate, so you straight away answer these 2 marks. But the behind part, you don't understand, also you don't care already. It is a good strategy, but make sure that try your best to understand as much as you can. Okay? Okay, so first, to build the table stating that F is in 100 gram. So 100 gram, you contain 85.7% as in the carbon, while 14.3% as in the hydrogen. So the first mark goes to mole, calculating the mole. So 85.7 divided by 12.0, you get 7.14. And then 14.3 divided by 1.0, you get 14.3. And you'll go to the simplest ratio. So 7.14 divided by 7.14, you get 1. 14.3 divided by 7.14, you get 2. So therefore, empirical formula in here is CH2. Okay? Okay, so this is the 1 mark for calculating mole. So 1 mark for empirical formula. Okay, so 2 marks in there. Okay, B, calculate the molecular formula for both gas A and B. Now, inside here, the question description are like this. That says that the product are passed through anhydrous calcium chloride, then through potassium hydroxide solution. So you need to explain what is the role of the potassium hydroxide and calcium chloride respectively. Okay, so calcium chloride is used to absorb sodium hydroxide. Sodium hydroxide is used, potassium hydroxide. Potassium hydroxide is used to absorb carbon dioxide, whereas calcium chloride is used to absorb this water in here. Okay. Typing error, supposed to be K. Okay, so now it is to say also inside the question, anhydrous calcium chloride and potassium hydroxide increased by 1.08 and 2.86. So 1.08 is for the water, and then 2.64 is for the carbon dioxide. So you divided by the RMM of water and also carbon dioxide. So eventually you get 0.6 mole to 0.6 mole. Okay, so this is the increase is due to the increase in the mass of water and also carbon dioxide actually. Okay, so you have to understand that on your own. Okay. Okay. Then from the equation here, CaHy plus MO2 give XCO2 plus Y over 2 H2O. So since 0.02 of CaHy gives 0.06 of H2O, therefore in here Y over 2 is equals to 3. Okay, so Y over 2 H2O so Y over 2 is equals to 3. That will make Y is equals to 6. Okay, and then for CaHy to form 0.06 mole of CO2, therefore X is equals to 3. Okay, so stating Y equals to 6, X equals to 3 will give you the other marks. And last but not least, mentioning molecular formula is C3H6 will give you the final marks. Okay. Okay, so that is for 18A and B. So now you know that A and B has the molecular formula of C3H6. So now, if it is C3H6, what could A and B be? So if you remember, CnH2n has two possible functional isomerism. So what is the two possible functional isomerism? So the two possible functional isomerisms are alkene and cycloalkene. Okay, so since it's the question saying that when mixed with bromine under sunlight, A and B both decolorize. However, only gas A decolorize potassium manganate, so B will not. So this will clearly tells you that A is an alkene, B is the cycloalkene. Okay, so what is A and B? So in here you have to deduce A is the propene, B is the cyclopropane. Okay, A is the propene, B is the cyclopropane. Okay, okay. Then you have to explain what is the reaction between bromine gas under A and under B. So propene react with bromine via electrophilic addition reaction, and of course you have to write equations to explain that reactions. Okay, so. Okay, so the equations in here, so CH3, CH double bond, CH2 plus Br2 is CH3, CHBr, CH2Br, whereas cyclopropane react with bromine via free radical substitution reactions. Okay, you have to explain that. Okay, so then definitely write the equation. Cyclopropane react with bromine under ultraviolet, so you form bromo cyclopropane plus HBr in here. Okay. So each of them 1 mark respectively. And last but not least, why is it that you can A can react with co-dilute alkaline potassium manganate while B cannot? Because A has unsaturated carbon, C double bond C. Okay. So according to the equation, CH3, CH double bond, CH2 plus MnO4 minus plus OH minus in co-dilute. So you form a diol. You form a diol in here. Okay. Okay. So with that. That is how you answer for question number 18A. 18, question number 18 in here. Okay. Okay. So is there any place that you want me to stress again for this one? So some of you might have asked a teacher, what happened if question want us to propose mechanism for these reactions? So to propose the mechanism for these reactions in here, so you might want to know on what is the correct way to propose the mechanism. So I try my best to draw in here for you lah. Okay, so inside the, why cannot draw? Okay, can I escape this for a while? Discard. Sorry, I try to this one. Sorry, give me 1 minute. Okay, I try to find out why cannot this one cannot draw. Okay. So I try to write out the mechanism in here, see whether you still can draw or not. Okay, so the mechanism for the cyclopropane still cannot draw. I don't understand why cannot draw. Supposedly can, isn't it? Sorry, pardon me for not able to know why I cannot draw the diagram. So never mind. I try to find the mechanism for the reactions in here and then shows you. Can or not? Can you give me like 1 minute? I shows you the mechanism part. The alkene part, right, need to write CCl4 or not? If possible, write lah. Impossible, write. Okay, possible, write CCl4. Yes. If possible, try to write the CCl4 part. Huh? Can you give me 1 minute? I'll show you on the way of how to propose the mechanism. Okay. Wait, sorry, take your little time. Because I'm going to show you the mechanism part in here. Back to the slide, shall we? Okay, Okay. Can Okay, so this is the reactions. Okay, so now what I'm about to show you is the mechanism part for the reactions in here. So if you are trying to propose a free radicals reactions, okay, cold dilute acidified. Okay, wait. I'm going to answer some of your questions first. Sorry. Okay. Wait, I'm going to answer some of your question. Teacher, what if it is cold dilute acidified? No such thing. No cold dilute acidified. You have to. They will definitely say that it's cold dilute alkaline. That is the correct reagent and condition. Only then they possibly acidify it. Okay, but so we in the STPM exam, we refuse cold dilute acidifier is cold dilute alkaline. Okay, and then number 2, alkene, no need to write CCl4. If possible, write. Okay, if possible, write. Okay, if possible, write. Okay, so now allow me to explain the mechanism part of how you should write your mechanism for the free radical substitution reaction. I cannot. I'm just going to use some examples that I already have. So in this case, it is this one. So you have to draw like this initiation. So you use the half arrow head. Half arrow represent 1 electron, full arrow represent 2 electron. So bromine first under UV you breaks to become 2 bromine radical. Then the bromine radical will attack the proton. Okay, and then homolytic fission take place in between CH3 and H to form the BRH and also CH3 radical. Then CH3 radical further attacked by the bromine, so you form the CH3Br plus Br radical. So the propagation steps will keep on propagate where the bromine radical will keep on. So that's why for propagation steps, I usually advise students to write at least 2 steps for propagations. Okay, so these are the 2 steps. And then finally for terminations, so you attack the bromine radical with the methyl radicals to form the CH3Br in here. So this is the part of the how you are going to propose the mechanism for free radicals reactions. Okay, so this is for free radicals substitution reaction. Then the next one in here is the this brominations of the alkene. So in the bromination of alkene, so try your best to propose in such a way where you have the bromine molecule attacks the carbon, okay, and then the C double bond C attack back the bromine, so you form the bromonium ion, okay, bromonium ion. So you form a triangle like this, okay. So bromonium ion, okay, some of you started to ask questions already. Okay, teacher, alkene react with Br2 under sunlight, not in CCl4. No, actually, even without CCl4 can still react. Even without CCl4 can still react. It can still react. Don't worry about it. Okay, because alkene very easily react. Okay. Okay. So back to this one. So inside here, okay, the bromine will form the bromonium, and the way of how you draw these bromonium reactions, if you notice carefully, if you notice carefully, one bromine is drawing down, another bromine is drawing up. Do you see that? Okay. One bromine is drawing down, another bromine is drawing up. So it must be in the Vic. We call it as a Vic isomer, Vic isomer. Okay. So when you propose the mechanism, we are even very details under such part. So teacher, why can it be bromine both are under the same plane? So the reason that they give last time in 2009 is due to steric hindrance. Okay, so you cannot have both bromine in the same plane. It must be on the opposite plane, as in like this. Okay. Okay, so this is the correct way of how you are going to draw the mechanism. So I hope that you learn the correct way of how to write the mechanism. So nowadays in STPM, even in 2020, we already stressed the mechanism part a lot already. So I hope that you'll be able to propose the correct mechanism when the right times comes. Okay. Okay, so with that, that is for question number 18. Okay. Okay, so shall we go to the next question, which is question number 19? Any else question that you want to ask about this? Okay, Okay, so no problem. Let's go to 19. 19A sounds like this. Optical active compound J with the molecular formula C4H9Cl undergo hydrolysis to form compound K. When K is oxidized using strong oxidizing agent, compound L is produced. As J react with magnesium and then react with compound L under acidic condition, compound M is formed. Draw all structural isomer for C4H9Cl, hence explain the structure of JKLM. Okay, so in this very, very big marks with the description, I usually advise students to write everything possible, okay, including describing what is the functioning group of JKLM in here, okay. Okay, so first of all, of course, we are looking for the 4 isomer for the J with the molecular formula C4H9Cl. Okay, the undergo hydrolysis, we have 1 chlorobutane, 1 chloro 2 methyl propane, 2 chlorobutane, and also 2 chloro 2 methyl propane in here. Okay, so which one could be J? Obviously, J is the 2 chlorobutane. Why? Because this is the only optical active J. Okay, this is the only optical active J. So you said you explain like this. This is the one that I show you in slide is just the standard answer scheme in here. But I hope that as a student in STPM, you say that J has a chiral carbon atom surrounded by 4 different atoms or group of atoms. Okay. Okay, then J react with the hydrolysis. So you have to write out the hydrolysis equation. Remember to put a triangle, show that it must be reflux. Teacher, what is the difference between heat and reflux? Both heat and reflux require heating. So just put a triangle. No matter heating or reflux, just put triangle. No need to specify the word reflux. Just put triangle enough already. Because in organic chemistry, inside the chemical equation, the triangle simplified by heating. Okay. Okay. So you write the equations for the hydrolysis reaction. So you have to mention that K is a secondary alcohol. Just like I said, just write secondary alcohol in here. Okay. Okay, and then in certain extent, they will also try to say that K can react with alkaline potassium alkaline iodine solution, because so you have to mention why K can react with alkaline iodine solution, but not in this question. But usually when it comes to this structure, they will usually couple with K can also react with alkaline iodine solution. Okay, but this time no. Okay, then straight away, J can also react, K react with oxidizing agent to produce L. So when you react with oxidizing agent, you produce L. So L is a ketone. Okay, so L is a ketone. Okay, so mention that. Since oxidation of the secondary alcohol produce ketone. So mention like that. Okay. Okay, then J react with the magnesium to form compound, and then react with compound L under acidic condition. So this is a Grignard reagent reaction. Grignard reagent reaction. So try your best to remember on how to propose a Grignard reagent equations. So CH3, CH2, CHCl, CH3 plus Mg gives CH3, CH2, CH, MgCl plus CH3 here. So you form a Grignard reagent, and then followed by acidic hydrolysis, react with ketone, followed by acidic hydrolysis. Okay, so when you react with ketone, you form the product M. So you have to even mention that M is a tertiary alcohol. Okay, M is a tertiary alcohol. Just mention like that. Okay, and this is the structure for the M in here. Okay, so just mention everything accordingly. So as a student, you try to describe everything as fully as you can. Okay, so with that, that is the structure of JKLM and what you should do to explain them. Okay, okay, any questions so far for this 19A here? Oxidizing agent, can we, so teacher, oxidizing agent, can we put bracket O? Cannot. Must put KMnO4/H plus under reflux. Cannot put bracket O. STPM do not accept bracket O. Okay. Okay, teacher, no need to dry ether and 35 degrees Celsius. Dry ether if possible, right? Dry ether if possible, right? Because of the limitation, sorry I didn't write dry ether, but actually magnesium you need dry ether but 35 degrees Celsius no need. Actually, you can even react under room temperature. Okay, no need 35 degrees Celsius. And then teacher, should we memorize all the temperature? Anything below 200 degrees Celsius, no need to memorize. Just simply put triangle to show that it is heating. Okay, no matter heat gently or whatsoever, no need to specify okay. Teacher, CH3, HCl also optically active? No, it's not optically active. No. Okay, can Okay, then later at the end of this question 19, we also include a little bit about how do we propose the SN1 and SN2 mechanism a little bit, because you need to familiarize with the SN1 and SN2 mechanism for this haloalkane. Okay, so I usually advise students in terms of the mechanism, try your best to understand them as much as you can. Okay, so with that, that is for the mechanism part of this one. Okay. So Ken, shall we go back to the slide in here? Okay. Don't worry. Okay, so teacher, what if I write O and KMnO4 together? As long as there is a KMnO4, then okay. As long as there is a KMnO4/H plus acidified, it must be acidified. Oxidizing agent usually acidified, except for the alkene just now, it is an alkaline, cold dilute alkaline. Okay, so no problem. The key in here is don't put bracket O Don't put bracket O. Okay, so that is for A. Then we go for B. Determine the isomer of J, which react with ethanolic potassium hydroxide to form only one organic compound. Give a reason for your answer. Actually, this is a very generous answer because you write any isomer of the J, all are correct. But it's the way of explaining why they only give one isomer is the one that distinguish them. Okay, so how are you going to explain them? Okay, so all answers other than J are accepted. So it can be 1-chlorobutane, it can be 1-chloro-2-methylpropane, it can also be 2-chloro-2-methylpropane, also correct. However, the way of how you explain them is slightly a little bit different. So why 1-chloropropane and 1-chlorobutane and 1-chloro-2-methylpropane give only one isomer? Because they are primary alcohol. However, if your answer you use 2-chloro-2-methylpropane, so you must mention that because it has similar surround group of atoms. Okay, so last but not least, definitely you have to state off the equations for it. Okay, so if you react with KOH, I forget to put reflux on the first one. You must put reflux also. Can you help me on do that? Okay, so it depends on what you use as your isomer. So they will give different alkene accordingly. If you use one chlorobutane, so you produce put one in and put two in. You must write both answer if possible. And then if you sorry, you only produce this put one in. And then if you use one chloro 2 methyl propene, so you form 2 methyl propene. And then if you use CH3CCl, you also form 2 methyl propene in here. Okay, side product, because this is an elimination reaction, so side product must be written. Okay. Okay, so with that, that is for question number 19. Okay, question number 19. Okay. Okay, any questions you want to ask for this? Okay, so as I promised just now, we will discuss a little bit about the mechanism part of this haloalkane. So why don't we go to the mechanism part? Okay, so now this is examples of how you should explain the mechanism for the SN1 and SN2. So primary haloalkane will undergo SN2 mechanism, substitution nucleophile in the second order. Well, this one, okay, sorry, I see questions ready. So teacher, when do we need to mention side product? Good questions. When do you need to mention side product? Elimination must mention side product because you are removing small molecule. So eliminations must mention side product. Condensation reaction. What are the example of condensation reaction? Esterifications, okay? This 2 amino acid react. Any condensation reaction, a reaction with 2,4-dinitrophenyl hydrazine is also a condensation reaction. That one must mention the side product, okay? And then what else must mention side product? Some of the chemical tests, you form silver mirror, must mention what causes the silver mirror. What causes the black brick inside the Fehling solution, Cu2O, you must also write the side product, okay? CHI3 for the toluene iodoform test. So that one is side product, must mention. What else must mention side product? The reaction, hydrolysis reaction. Hydrolysis, especially with amide. Hydrolysis with amide. So later we have one part of that question we will discuss based on that. Okay. 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 The mechanism, no need to write side product, only write equation. Yes. No need to write side product. We only need to write. Actually, mechanism is more on how you show the reaction take place. How you show the reaction take place. That is more important than anything else. Okay. Okay, so okay, let's go to the mechanism part. So as you can see in here, this is the SN2 mechanism. So in SN2 mechanisms, you need to show on how does the first OH minus attacks the carbon like this. Okay, OH minus attack the carbon, and then CCl cleavage take place. So all of this happen in one step. So that's why this is a one-step reaction. Then you need to show this intermediate. So this is the sign for intermediate. It looks like 2+. It's not 2+. This is a sign for intermediate. So you must also write that inside your intermediate. And then this one is partial negative. Okay. However, because O has a shorter bond length, so O is harder to break. CCl is easier to break. So that is why Cl is already ready to move to the group, and you form your desired product. And if possible, slow step and fast step must be mentioned. Okay, so this is for SN2 mechanism. And then for SN1 mechanism, so you first show on how carbocation is formed. So SN1 mechanism is usually for tertiary haloalkane. So you need to first show how the carbocation is formed. Okay, so the CCl bond in here broken to form the stable tertiary carbocation, then followed by the OH minus attacks the carbon to form your desired alcohol. Okay, so that is why it is in this two-step reaction. So these are the energy profile. Sometimes there is 1 year of STPM that use the energy profile to ask you what is the type of the reaction take place, whether it's SN1 or SN2 mechanism. Okay, so these are the things. Questions. Wait, I see questions in here, so I'm going to show the question to the viewers. What type of mechanism secondary haloalkane undergo? It can be both SN1 and SN2. Okay. You can if let's say lah, your questions there is 1 year 2015 if I'm not mistaken that that use a lot of answer can be primary haloalkane, secondary haloalkane, tertiary haloalkane, and then at that moment, anything if you put your secondary haloalkane as the answer lah, they accept both SN1 and SN2. So it is more to mechanism rather than what you used for the mechanism. Okay, but STPM seldom lah have such variations lah. Okay, so teacher, is lone pair electron or OH must be shown in the mechanism. Try your best. Try your best to draw the lone pair electron inside the OH. Try. Okay. Sometimes they accept, sometimes they don't. I cannot say for sure. But as a student, I will usually advise students to write out. Okay. To write out. Okay. Okay. So these are the mechanism part for the haloalkane. Okay. Okay. So I hope that nothing much already. Okay, so with that, that is for question number 19. Okay, any question else that you want to ask regarding to haloalkane chapter? Can Okay, so no problem. Immediately we move to the final questions, which is number 20. So number 20 is regarding to this carboxylic acid and its derivative. Excuse me for a while. Okay, carboxylic acid and its derivative. So 20A sounds like this. Since 20A and 20C are reaction scheme, so I put them all in one question. Hope that you understand. Okay, so outline the reaction scheme of how you produce N-benzyl ethanamide from benzene. Okay, now when I show this, when I give this question to my students, some of them, because they look at C, they will think of changing to become acyl chloride and then become the amide, isn't it? But actually, don't need to undergo to such extent in here. Okay, so in here, you have to understand that the one that is working in here is the amine part. You have to change this benzene into amine. Why sometimes cancel cannot lah? Aduh, apa masalah ini? Aduh. Sorry lah, I don't understand why is it sometimes cancel cannot. Okay, what am I trying to say in here is how do you change the amine part into the benzene into the amine? Okay, so to change benzene into the amine in the reaction scheme, we always look for the shortest possible methods. Okay, so this, since there is 7 mark, so you must have 7 things. Okay, so what would you propose? So starting from benzene, first definitely is you add CH3 lah. So you use CH3 in AlCl3 under reflux, so you form toluene. Then in toluene, okay, some of the students, most of the students will write oxidation, and then oxidation you become COH. COH, then you become CONH2. CONH2, then you reduce, become NH2. Actually, if you do that, you have more one step. That is actually a shorter way. What is a shorter way? You react with chlorine under UV to form this chlorotoluene, chloromethane, benzyl chloromethane, okay? And then you react with concentrated ammonia in ethanol under reflux to form this NH2. So that is the shortest possible way. Okay, shortest possible way. Okay, only then you add acyl chloride to form the desired secondary amide in here. Okay, so this is the possible way. So if you count properly, this one is 1, 2, 3, 4, 5, 6, 7 marks. The shortest, the most perfect way to get to your answer. Okay, so not by forming Cl lah, then change to amide lah, then reduce lah. No. That is too long already. Okay. No, they will not. They will not accept any path which is the short. Teacher, they will accept any pathway, right? If not the shortest, no, they will have to accept the shortest. 7 marks is fixed to that. So teacher, what happens if I propose the longer methods? Will I be penalized for everything? Not really. It depends on how you propose your mechanism. Sorry, how you propose your reaction scheme. As long as the chemistry is correct, along the path, definitely some of them are right. For example, this one, the CH2, at the end you got CH2NH2, isn't it? You have to react with SU correct to get your product, isn't it? So this one, if the chemistry correct, we still give 1 mark. This one 1 mark, this one 1 mark, and this one 1 mark, 4 marks. Okay, but the middle mark, this one, we will not give. Okay, so these are how we mark in STPM. Okay, so we always look for the shortest possible way. Okay. Okay, so this is for A, and then we go for C. Identify the reagent necessary to follow the transformations. Okay, so COCl and CH2NH2. So very direct lah. So as you correct, you first react with ammonia under reflux to form amide. Amide, when you reduce, to become the amine in here. Okay, so most of the students in my school because they see this reaction, so they see these reactions in here, so that is why they propose this reaction scheme. I mean, you use the COCl to become the amine in here. Okay, but don't worry, don't be too naive. STPM won't be so naive one. Okay, so this is the best way. Okay, so with that, that is the how you are going to propose for the reaction scheme for 20A and 20C in the carboxylic acid derivative. Okay, any questions that you want to ask? Okay, so if no problem, then we go to the final questions, which is 20B. Okay, state the product form when N-benzyl ethanamide react with the following reaction. So that is N-benzyl ethanamide, boil hydrochloric acid, boil sodium hydroxide, and lithium tetrahydroaluminate in dry ether, followed by acidic hydrolysis. Okay, so in here, when they ask for boil HCl, it's definitely this hydrolysis. And when it comes to hydrolysis, all products must be written, especially for amide, because in amide, when you hydrolyze, so NH and CO in here will be broken. This is the part that will be broken. And you have to remember by heart that amine is basic, carboxylic acid is acidic. So when acid cannot further react with acid, but the basic part of the NH2 will further react with the HCl. So that is why in here, the answer for number 1 is you will form the salt CH2NH3Cl. So in this case, strictly must have HCl because question use boiled HCl. If the question use boiled HCl, then the HCl must be in your answer. So you cannot leave as CH2NH3 plus full stop. Cannot. Unless the question said acidic hydrolysis, then you can leave your answer as CH2NH3 plus. Okay, so in this case, because they say that boil hydrochloric acid, so you must include HCl in your answer. And then the second species, organic species, is the ethanoic acid, CH3COOH. Okay, and then for number 2, boil sodium hydroxide. So in here they use boil sodium hydroxide, so you form the amine and also the salt of the carboxylate salt. Okay, so in here your answer must write CH3COONA. Positive, negative sign not compulsory. Positive, negative sign not compulsory. The only compulsory positive, negative sign is just now question number 17, benzene diazonium chloride. Benzene diazonium chloride, yes, positive, negative must be written. Okay, but for this one, no need to write. Okay. And last but not least, lithium tetrahydroaluminate. A lot of students confuse amide with ester. Yes, ester when reduced will break to become 2 alcohol. But when amide reduced, they will become the respective class of the amine. Primary amide become primary amine. Secondary amide become secondary amine. Tertiary amide become tertiary amine. So you will not you will not break to become 2 other compounds. Okay, student often tends to confuse with the ester part. Okay, so with that, We finished all 20 questions already. Okay, just now I promised you that some of you started to ask the mechanism of the this one, isn't it? So I'm going to show you the examples of the this mechanism for the aromatic compound. Okay. So we go back to this one. Okay, so as for the aromatic compound mechanism, okay, so this is the way of how you are going to propose the electrophilic aromatic substitution reactions for the benzene. So you must use the Kekuli structure. Yes, you must use the Kekuli structure to propose your mechanisms in here. Okay, so the first step is where chlorine undergo heterolytic fissions to form the electrophile of the CH3 carbocation, and then the carbocation attacks the benzene ring, so to form the intermediate. Okay, so this intermediate must draw like this. Last time in the senior teacher will teach us you how to draw the half moon thing. Half moon thing is no longer accepted by the STPM anymore. So you have to draw like this. Okay, and then step 3 is the deprotonations of the complex ion. So that is how you have proposed in here. Okay, okay. So I have questions. Okay, so teacher, if question asked to compare rate of reaction between SN1, SN2, which one is faster? No such thing. There is no such thing for sure. However, if they want to compare rate of hydrolysis, we would say that tertiary haloalkane has the highest rate of hydrolysis, followed by secondary, then primary haloalkane has the lowest rate of hydrolysis. Okay. So tertiary haloalkane is the fastest, then secondary, then primary. So don't worry, they won't ask you to compare which one SN1, SN2, which one is the faster. No, because each of them has their own different way approach. So we cannot say for sure SN1 faster or SN2 faster. Okay, it's just that their approach is different. Okay, so I hope that I answer to your question, Miss Alice. Okay. Okay, what else? So now Q&A session. I forgot to type in Q&A session. Okay, so wait. Okay, so let's have a look on what are the questions that you throw to me. Okay, so is there any difference between FeCl3 and LCl3? No difference. Don't worry, it's possible catalyst. Okay, no difference. Okay, okay. Other than that, no more. Sure, no more. I'll wait until 1:45. And then if there is any, you better ask because okay, teacher, how to identify whether benzene ring is a side chain or not? What do you mean? How to identify whether benzene is a side chain? Oh, you mean when it comes to name, when how to identify benzene is a functioning group or not? Is it? So benzene, if terms of naming naming of the aromatic compound, if it is a saturated hydrocarbon, then if it is less than 6C, then benzene will act as the functioning group. If it is more than 6C, then benzene will act as a substituent. Substituent name for the benzene is phenyl. Okay, phenyl. Okay. Okay, what else? Today I only have around 200 plus viewers. The highest that I saw just now is 238. I don't mind actually because I'm doing it for free. So this is the time where you can really get me to answer your questions. IUPAC name for ITER. IUPAC name of ITER is not in our syllabus, so don't have to bother about it. Okay. Teacher, should the iodoform test equation need to mention the mole and the physical state? No need. Okay. This one, can I show you the slide? I will help you and whenever way I can. Wait, can you give me 1 minute? 1 moment. I show you. Okay. Yeah. Okay, so this is the examples of how we compare between aldehyde and ketone functioning group. Okay, so when you try to write the equations for the reactions inside the aldehyde and the ketone as the functioning group lah. Okay, so I'm going to put down your comments. Sorry, I'm going to put down your comment for a while. Okay, so if you look carefully inside the equations in here, the most important key for here is you are a Fehling solution. You must have Cu2 plus OH minus under reflux, the correct organic compound, and also Cu2O. And then if you use Tollens reagent, then it must be you must have AgNH3 2 plus with OH minus under reflux, then the correct organic compound, which is the carboxylate ion with the silver mirror Ag. And then finally, if you are using iodoform test, important keyword I2 in OH minus under reflux, you form the desired carboxylate salt, and then yellow precipitate CHI3. Some of the books they write all the side product are HI, water, all this and that. No need to write, never mind. So these are the important key inside writing the Tollens reagents in here. Okay, so I hope that I answer to your questions. Okay. Okay, I see. Let us check other questions. Alkene react with HCl and alkene react with NaOH are the same. Hey, alkene does not react with NaOH. NaOH don't have electrophile, so cannot react. Okay. What is the difference between name of a reaction and type of reaction? Everything type of reaction, don't name, just put type. Alkane free radical substitution reaction, alkene electrophilic addition, benzene electrophilic aromatic substitution, haloalkane, it can be nucleophilic substitution reaction, SN1, SN2, straight away state the mechanism, and then or it is an elimination reaction. And then there is this carbonyl. Carbonyl, you have nucleophilic addition reactions. Okay, so everything just right type of reactions. Okay. Okay, teacher, Br2 with FeBr2 or FeCl3, is there any different? You must always try your best. If you use Br2, you must couple with FeBr3. If you use Cl2, you must couple with FeCl3 or AlCl3. Don't mix. Don't mix. Okay, don't mix. Because actually, some of them might have side effects if you mix them. Okay, so cannot. Haloalkane. Do we need to type preparation of HCl in the nitration? Mechanism, yes. You have to propose the mechanism, yes. If name compound must give IUPAC name only. Yeah, you have to give IUPAC name. Most of the time, STPM question definitely ask you what is the IUPAC name. They won't ask other than that anymore. Haloalkane react with HCl and haloalkane with react with NaOH are the same. No, because haloalkane react with HCl. My God, haloalkane cannot react with HCl . Hey, don't mix up the concept. Please don't mix up the concept. Okay. Phenol react with AlCl3. How to write the equation? Phenol does not react with AlCl3. No. Phenol does not react with AlCl3. Why phenol must react with AlCl3? Okay. Phenol, however, okay. You all, I tell you, you all must be very, very hardworking in comparing some of the side reactions, Now, I'm going to show you one slide. that compare between some of the very important reactions. Huh? Okay, so you are going to compare some of the very important reaction, and I'm going to show you a few of them which I feel that they are very, very important. Okay. Okay. Can you give me 1 minute? I show you some very important reactions in here.我没有写到咩？我 delete 掉了那个 slide。How come? Wait. Can you give me like 1 minute? Sorry, I just want to make sure that this one. Sorry, a little time in here. Wait, give me 1 more minute. Sorry, I find the slide for you. Teacher, can I have the soft copy of the slide? Soft copy of the slide is off limit. For teacher, yes, teacher, you can ask from me. Student, sorry, you cannot ask from me. Student, I will not share. Okay, yeah, one more. I straight away compare ones and all. For me, you need to do your own table of the comparison. Only then you'll be able to see what are the important things, what are the main difference in all these things. Okay. Can? Okay, so I'm going to show you on some of the comparison. Okay, now this is a very important comparison when you compare, for example, phenol and also cyclohexanol. Okay, phenol and also cyclohexanol. Okay, so I'm going to put down this. Okay, so phenol can react with sodium. Cyclohexanol also can react with sodium. Phenol can also react with sodium hydroxide, but cyclohexanol cannot because phenol is a stronger acid than alkyl alcohol, therefore more readily to react with alkaline. Now, in terms of PCl5, phenol cannot react with PCl5 and SOCl2, but cyclohexanol can form the chloro and cyclohexane. In terms of oxidation, phenol cannot oxidize, but cyclohexanone can. And then carboxylic acid. This is very, very important. Phenol cannot react with carboxylic acid, while cyclohexanol can. If you catalyze by the concentrated H2SO4. Okay. If phenol want to become ester, the only way is by using acyl chloride. Acyl chloride and then must be added to alkaline condition. Okay, must be added to alkaline condition. Okay, so this comparison is a very important comparison. So later after the talk, you might want to print screen right now, also can. Or later the YouTube, you can rewatch back to get this slide. You can copy, paste, you can print screen, and then you can, this one. Okay, so it's up to you already. Okay, I'm going to put down my face so that you will not, I'm going to remove my own face. I'm going Okay. Okay, how about Brady's solution? Brady's solution is 2,4-dimethyl phenyl hydrazine. Must write the reactions. Okay. What equations we need to be balanced? Actually, most of the organic reaction no need balance, never mind. The most important thing, if you really insisted want to talk about balance reaction, neutralization is the only one that you need to balance. Neutralization. The rest no need balance. Okay. Equation for other form that's no need balance. Teacher, what group can undergo hydrolysis? Now there is this reactions that what group can undergo hydrolysis. Okay, remember, bear in mind, haloalkane react with NaOH, undergo hydrolysis, and then the nitrile, okay, CN can undergo hydrolysis. Acidic hydrolysis and alkaline hydrolysis are two different things. So figure out on your own. My books also have, my YouTube also have. You can go for the nitrile, also inside the haloalkane chapter. And then this carboxylic acid derivative can also undergo hydrolysis. Okay, can also undergo hydrolysis. Okay, and then last but not least, you have this one. Yeah, can you give me 1 minute? I shows you the examples of the hydrolysis reaction. Okay. Yeah. Okay, so I'm going to show you hydrolysis reactions. Okay, so this is the hydrolysis of carboxylic acid derivative. So when you react with acyl chloride react with water to form HCl in here. Okay, to form the HCl in here. Wait. Okay, I'm going to put down your comment so that I can hide. Okay, so you also need to compare rate of hydrolysis in between chlorobenzene, haloalkane, and also acyl chloride. So why does they have different rate of hydrolysis? You can later watch back this YouTube, you screenshot, and then you look back at the reasoning that I in here. Because of the time constraint, I cannot explain everything in here because I also have another hydrolysis that I want to show you. Okay or not? Okay, sorry. You later you can screenshot lah. Okay, I put down my Okay. Okay. Sorry, because I have to add this to my stream in order to sound. So you must see my face by hook or by crook. Sorry. I don't know about that. I'm still new towards this StreamYard thing. Okay. Sorry. I don't know. For the reaction of methyl benzene and chlorine, the Cl can be on auto and para position. If they ask us to draw mechanism, should we show on auto or para? Actually, one is enough already. Don't have to show both auto para. Okay. Sorry, I didn't know that if I close my face, then you cannot hear me anymore. I don't know. Sorry. So some of the part you cannot hear me. Sorry for that. Sorry, I don't know. I'm still new in this StreamYard thing. Okay. Okay, what else? So for more information, you can always revisit back to this one. And then for teachers, if you want the slide, you can private message me. Students, sorry, I don't share slide with you all. Sorry for that. Okay, please understand because no, I cannot give student too much. Okay, later you all become lazy. Actually, you must be very, very hard. Okay, teacher is another case because teacher, you have a lot of things to do. Okay. Can? Okay, so I see no more questions already. So okay, so I guess that is all for our talks today. 2 hours, just nice. Okay, so I hope that today's talks helps you to understand better on how to answer organic chemistry question. You must be very, very hardworking on organic. Actually, organic is not that difficult, but if you cannot understand, you definitely not score in organic. You might even fail in organic. Okay, so do your very best. Do mind map every day. Go to my blogspot to download all the materials that you need. And I'll see you all next time. If let's say time permitted, then I'll do another lah. For the reaction with bromine water, can bromine occupy auto-para position when react with methyl benzene? Cannot. Tak boleh. Phenol and aniline are two very specific case because NH2 and OH are very strong ring activate group. Okay, cannot. Okay, what else? Okay, so if nothing else, I guess that is all for the talks for today. I hope that you all enjoy and benefits from the talks today. If we have chances, I will do a second talk. Let's say if I'm not occupied, then I can do this one. Refer back to the slide I show already. I already showed just now. You can refer back to the slide I show already. Okay, sorry. I show in here. This one. Comparison. Okay, this one. Okay. No need to balance. Just write the product. Fe3 plus O3 minus. You observe purple solution in here. Okay. Okay, what else? Okay, so I guess that is all for our talks today. So thank you very much for having me to share with you. So if there is future, we will be able to discuss together again. So I guess that is all for our slide today. So I guess I see you all other times. Okay, so good luck for your SEM 3. Have a nice day ahead and see ya. Okay, bye. Okay, so I end my broadcast already.